This video is going to talk about how we can use prime factorization to find a GCF. And GCF stands for greatest common factor. So that's the biggest factor that two or more numbers have in common. So let's do an example here. So let's go ahead and do 8 and 12. So we're going to look for the greatest factor that the two numbers have in common, and we're going to use prime factorization. So remember, prime factorization is when we break the number down into a string of prime factors. So I'm going to go ahead and start by breaking 8 into 2 times 4. And then I need to break the 4 down because the 4 isn't prime, so I can break that into 2 times 2. And then I can bring that other 2 down because 2 times 2 times 2 equals 8. Then I'm going to come over and do the 12. I'm going to start with 3 times 4 equals 12. Then I need to break that 4 down because 2 times 2 is 4, and those are prime factors. And then let's go ahead and bring that 3 down because 3 times 2 times 2 is 12. So I have my two prime factorizations. Now, the greatest factor that they are going to have in common is going to be the product of all the factors that their prime factorizations have in common. So let me repeat that because that's kind of a heavy thing to comprehend. The greatest common factor is going to be the product. So remember, product is the answer to a multiplication problem. It's going to be the product of all the factors that they both have in common. So I see a 2 over here, and I see a 2 over here. I see another 2 over here, and I see another 2 over here. There's another 2 over here, but there's not one over here. So I can't circle this other 2 because they don't have it in common. And over here there's a 3, but there's not a 3 over here. So I can't circle a 3. So they have two 2's in common. So the product of the two 2's is 2 times 2. Now notice, I'm not taking 2 times 2 times 2 times 2. I'm just looking in one prime factorization, what they have in common. They both have two 2's, and 2 times 2 is 4. So the greatest common factor of 8 and 12 is 4. Now, think about that. Does it make sense that the biggest number that goes into both 8 and 12 is 4? That does make sense because the only bigger factor of 8 is 8, and 8 doesn't go into 12. So this answer does make sense. All right, let's try another one. Let's try the greatest common factor of 20, and let's go ahead and do 30. All right, so let's do prime factorizations first. This is great practice for prime factorization. So I can break this into 2 times 10, and then I can break my 10 into 2 times 5, and I'm also going to bring my 2 down because 2 times 2 times 5 is 20. Let's come over and do my 30. I'm going to come over and do 3 times 10, and then I can break my 10 into 2 times 5, and then bring my 3 down because 3 times 2 times 5 is 30. So let's look and see what these two prime factorizations have in common. I see a 2 over here and a 2 over here. And I could have circled this 2. I just chose this one because I also saw they have a 5 in common, and it was just right next to the 5. So that's why I chose that one. This has a 2, but this doesn't have another 2. And this has a 3, but this doesn't have a 3. So the greatest factor they will have in common is 2 times 5, which is 10. Now notice, guys, the 10's up here too. That doesn't always happen in this, but you can see, hey, 10 is a factor of both of them. And in this case, it does happen to be the greatest common factor. All right, we're going to try one more. And if you're feeling pretty confident in this, I would ask you to pause the video and try it yourself. See if you can do one on your own, and then you could restart the video and see how you did. So let's go ahead and do 32. And 40. All right, so let's break 32. I'm going to break it into 8 times 4. We did this one in another video, if you watched that video. 8 is the same thing as 2 times 4, and I'm going to bring that other 4 down. Then I can break this 4 up into 2 times 2. And if you're really confident in prime factorization, you could go ahead and break that other 4 up at the exact same time and then pull this 2 down. So 32 is 2 times 2 times 2 times 2 times 2. There should be 5. 1, 2, 3, 4, 5. Just checking myself to make sure I did that right. I'm going to break the 40 into 2 times 20. I could also do 4 times 10, but I'm going to choose to do 2 times 20. And then I'm going to break it into 2 times 10 and bring my other 2 down. Then I'm going to break my 10 into 2 times 5. And over here, I'm going to bring my other 2's down. So 40 should be 2 times 2 times 2 times 5. All right, let's look and see what these have in common. So I see a 2 here and a 2 here, another 2, another 2, another 2, another 2. Now, this one has a 5, but there's no 5 over here. And there's no other 2's over here. So it looks like my greatest common factor is 2 times 2 times 2, which is 8, because 2 times 2 is 4, 4 times 2 is 8. So here, the greatest common factor is 8. If you need more practice with this skill, you could always make up some more problems and just practice using this prime factorization to find the greatest common factor.